Good. Okay. I gave 6 subjects you could choose from where I could say something about it. Then it was chosen to have learning analytics metadata standards for this open conference. And tomorrow I talk about learning analytics supported instructional design. What is more educational related? Who of you are technical persons? Raise your hands. Okay, half. Half. Okay, and the other ones are educational persons or totally different subject? Who's educational expert? 1, 2? Okay. And the others are just interested or have background in a specific topic. Okay, great. So I hope, then I think you can learn a lot here. I tried not to make it too boring talking about standard Y, X, Z, rather than talking practically. Just a few words about myself. I'm associate professor at the Open University of the Netherlands. My topics have been recommender system. This is where I did my PhD thesis in 2006 to 2009. And like Julia already said, what we did at this time was already learning analytics, but nobody called it learning analytics at that time. So we used data from our students, and a friend of mine made this nice gimmick. What we actually did here, you have our students somewhere in the space of the Open University totally alone. And then they have some interaction in a forum or something where they communicate and some information is changed. And we found little paths, and we found some successful paths. And we recommended, in my thesis, we investigated how to recommend these successful paths and steps to the student. So at that time, we called it navigation support for learners in informal learning networks. Well, today you would say MOOCs instead of learning networks, and you can change it. But actually, we do learning analytics since years, so that's not totally new. Nevertheless, it's the new buzzword like MOOCs, learning analytics, so I added it to the list. Personalization is also one of the things. Once you have the data, you can also provide personalized access. Mobile devices came because I work with Markus Specht together, who is professor in mobile devices, so we added also a lot of mobile stuff to it. And I applied it for schools, higher education, and especially for the medical education field, because I have a good contact with medical educators, and the nice thing about the medical educators is they are so conservative. So what we do now in some subjects, they will do in 6 years. So you can come with all that stuff you do now, and that's for them, it's amazing. So that's a nice win-win situation. At the OU, so I'm from a research center really, yeah? So I have a different time schedule than you guys might have. So in the past I have 100% research I was allowed to do. Now I have 20% teaching, 80% research. So we run a lot of European projects. So I'm founder of the DataTel, so that was before learning analytics, a special interest group for using technology-enhanced learning. Then we have within the Netherlands, where I'm from, a special interest group on learning analytics, where all the universities work together on a topic. And within this presentation, I will show you how these synergies works between the universities. Then Linked Up is a project about linked data for education that we completed last year. Currently, I'm working in the LACE project, what is Learning Analytics Community Exchange Program. Alter Ego was another project about data search, and I'm an executive member, so I was voted for being executive member for the Society of Learning Analytics. So I meet with these guys. It's terrible calls because the people are spread over the whole world. My time zone is then 11 o'clock at Thursdays evening, others 7 o'clock in the morning, and then we discuss how to push the Solar community further, and we organize the Learning Analytics Conference. The next one is in Edinburgh. The deadline is end of the week, so I already wrote my papers for that. So Learning Analytics, whatever we do, we made a very easy framework. I did it together with Wolfgang. It's open source, so when I can also give the slides later on, you can always find the articles back if you want to see something, some more details about it. So we made this learning analytics framework in 2012 to establish kind of what learning analytics is about for us. And it has been very attractive also for our teaching staff, but also for other people that work on learning analytics and want to explain what the added value is for other members like teachers, for instance. So we have then these 6 domains. What is the stakeholders we are working for? Then the objectives of learning analytics, it's most of the time reflection about a process and prediction of a process. You can boil it down to these two objectives. Then you have educational data. Most of the time there is protected data because of privacy and other things, and there are open data sources you can use also to enrich your data. Then there are different technologies like educational data mining, recommender systems, statistical analysis, whatsoever. Visualizations is missing. We need to add that actually. Then there are constraints, especially in Europe, what is about privacy and ethics, and that makes us sometimes really a hard life. Who of you knows about InBloom? InBloom, it has been a $100 million investment in the US, what failed because of privacy. So privacy can be a showstopper for learning analytics if you don't address that in a proper way. So just to give you some key facts, so InBloom has been an association in the US that take the data from the schools, so really K-12, and put it into one data center. And that was a very advanced system with different access rights, and they did the prediction and the reflection stuff for the schools. And all the counties of the US have been part in the board. So it was really run by the government, actually. And they got an investment from the Bill Gates Foundation and other foundations. There have been no company involved. But at a certain amount, they did not communicate properly what they do. And then some of privacy lawyers and parent organizations run mad and put into the news, they take away the data from the kids. They have been afraid that this data will be taken, will be sold to Google or whatever, and that they already then fish for the good employees of the future and so on. So they have a lot of things made them very scared. And that happened that the counties needed to step out of this board, of this $100 million investment, and then InBloom failed because they did not communicate properly. They did not have a transparency thing. So privacy and ethics is an important thing if you work in that domain, especially for K-12. But it's solvable. It's not like, there are ways to address that in a proper way, and it's also something we work on at the moment. And have a checklist that we will submit to this LAC conference I just said called Delicate. That's a nice acronym with Delicate, where you have to check all the boxes. Something I can share as well. That is matched with European law and how you can address that to make trusted learning analytics. So and finally, competences with, if you have learning analytics, you need to interpret the results you see. You have to know about the data that goes into that, and you need to have a critical thinking if this is really, if this is the data you can trust. I have some schools in the Netherlands. The school sector is it's very different to Germany, I think also to Spain, because it's driven really by companies partly. Huh? So the schools have really a budget and they can really invest stuff and so on. And there's a lot of companies also in that field. And then some of these learning analytics companies, they put a black box to the teachers. So they just put it here, and then the black box does some computation and predictions. And then, for instance, you learn math as a child, but the teacher cannot explain why the kid is doing this math stuff at the moment, because it comes out of this black learning analytics box, and it's the best algorithm that predicts the best results for the kid. What is a very scary thing, and I would be really pissed off if I would talk to the teacher and tell, why is my daughter doing this? And they would say, I don't know, well, it's this magic box from Acer, this Acer box, and it's the best teaching and personalized learning you can get. So there is something about this, and I think this is not the way it can be. I think we need also in schools kind of data stewards or people that know about the data, that can deal with the data. And in the Netherlands, we work towards that in these higher couples, umbrella organizations. They become data scientists within the schools that know about their things. So that's a vision. So this is kind of backbone of all the research we do. And for each of these things, I can pick studies and other things underneath. And we try to really pick a holistic approach to that. So it's not that I come only from data mining or something and just you give me a data set and I do some predictions and I put it out. So we really try to put it in a holistic way. Okay, what I want to do today is why learning analytics standards might be needed. Actually, I'm not a standard guy, not at all. I find this super boring. So I hate talking about IMS 3, LOM, level 2, whatever. That's really not my thing. I just do it because it's needed at the moment, yeah? So what data standards are out there. So I will give a rough overview of data standards, and then I will talk about 2 data standards I worked with, and so they're really in the field and they are working. So it's not like these holy grail data standards that nobody really is using, but some things that are used. Then I will show you an example of XAPI as we apply it in one research project, and we also apply it within the university. That's totally new stuff. You see it as the first audience ever, right? And it's also going to that paper for luck, so please be quiet. So it's unpublished. Then I show you different designs of learning record stores where all the data goes to, and I give an outlook of where that might go to. So that's a bit what I want to work with you guys. And if there's any question, just raise your hand, say something. I mean, let's talk to you after. Otherwise, I talk for half an hour and you kind of slip away. Learning analytics sophistication model, and I think that's something that's also very interesting for WOC, because I think you guys are really advanced. What I saw so far. So that's something come from the Society of Learning Analytics. It's a sophistication model when you become a kind of data-driven organization. Yeah. And if you see that, you become aware that data it needs to be something you should do, then it's basic reports and log data is used to do some reporting. Then experimentation, so you have some drill down reports and some sample dashboards that you already apply for one course or something. And then you get to this level where you have cross-system data integration, and that's pretty high level. So from studies we did, most of the universities in Europe are somehow between level 1 and 2. But I think you guys already definitely at level 3. What you should become aware of that that's this kind of really leading role at the moment. Then from there you go to predictive models. So level 4 predictive model, organizational transformation. And from then you really step into being a data-driven association where you have data sharing capabilities, you have open data, you have innovations coming out of the data, really information processes. So that's the learning analytics sophistication model. OU is between 2 and 3, so we are pushing hard to 3, but we really have to follow some formal rules that really slow us down, because I need to sign tons of paper that there will be ethically going on with these data and so on. So it's a tough process for the whole organization. Okay, what we have at the moment is we have something like this, and I think you have that as well. You have thousands of tables where the data of your students is. You start with marketing, does stuff. I don't know what marketing does. Then we have the contact point. We have 16 study centers at the Netherlands, and also one in the Netherlands and Tillen. I never been to, unfortunately. And so all of them store some data in some way, and we have totally no clue how that all fits together, actually. So that's one of the issues, heterogeneous tell systems, and that's all not made for learning analytics. I mean, that's all served a certain purpose. So for instance, the marketing, they just track where we send the calls to, how many people react on that, but it was never made for the sense to you learning analytics to get students into our system, to support them in the best way, and to get them as fast as possible and with high grades to their diplomas. So it was never intended for this, but this is the data we play now at the moment. It's really messy data, actually, not intended for learning analytics. So I think that's also one of the big points why we need that term of learning analytics. What I did in my PhD thesis was playing with data that was messy, kind of, that was not intended for these recommender systems. But now with learning analytics, we need this umbrella term because we want to have a different kind of treating the data and treating the students, and this is why this new term has a right to be there, I guess. So various heterogeneous data sources, there's no metadata standard. I mean, there are tables, just people invent tables and columns on the top, whatever they needed. No proper description of data fields. No unique user identification, actually. That's also a funny part. So some systems have a different identification than others. Only when you're really in the university we can do that, but there are satellite systems around where we don't know how to match those systems. No intent for evaluation and of educational interventions. So we never intended. So at the moment we still send. You have to think about it. It's the 21st century. We still send surveys to our students. How did you like the course? And then we get a response rate of 50%. And then we only get the response of the people that are really pissed off or the people that really liked it. And they tell us what it is. And that's our evaluation, how good we are. And I mean, with learning analytics, we can follow them, what they're doing, and we get actually 100% response rate back. So this is where we need to go to. Yeah, and there's no comparison of effective methods. So how a certain intervention, what kind of effects they had. I will give you one example of a recommender system study from a PhD of mine. Normally, you have then things like how to generate more accurate and thus more relevant recommendations by using social data originated from social activities users. So it's a very specific, well operationalized research question. And then we run that. So recommender systems, you have then different approaches you can choose here. For instance, you have then user-based filtering, where you really look for what did a target user do with certain content, and then you compute the similarity to another student, and then you can make some recommendation to that person based on the similarity of their activities. That's user-based filtering, actually pretty old stuff. When you look at the first recommender system papers, really funny. Then you can go back to, does any one of you know news groups that you can, and then you get these news groups in. So there they applied these algorithms already in 1914, and they still do it. And when you read a recommender paper, it's still the same. There's a flood of information. How can we filter it? We look for similarities, and this is what we found. So then what Amazon is doing when they recommend you the stuff you already have to you, they do content-based. So they have for all the items the correlation and make then recommendations to a target user based on other people that bought something like this. You know that. Then in 2012, we did a study of, because we need to have comparison data. If you do a recommender system study or whatever study and you want to improve an algorithm, you want to show this algorithm is better than the other algorithm, you need comparison data, you need reference data. So we looked what kind of data is actually available in the educational field that we can apply. And we listed all these different data sources and classified them according what kind of information is stored there. So then you from Datatel, there have been certain data sources collected. Then you have this Pittsburgh Learning Center data shop, what is a very strong player, but they only have intelligent tutoring system data. And there was the MALSE project, and we clustered them in 2012. This picture totally changed. I mean, 3 years later, we have plenty of more data sources you could use due to learning analytics. Yeah, okay, so we identified this then, and well, what I want to mention here is it's important to report the effects from one algorithm to a reference data set. So I take now our data set, Open University, what is very specific to us, but I also take MovieLens, a very common one, or I take Apostle data set or whatever, for my data study to show also the effects of my algorithm on these other data sets to compare at the end the data sets. That's a very important point, and this is why we need data interoperability in a certain sense. We need to understand how we communicate with each other, what the data means. And this is also how ACM recommender systems or the KDD Cup associations do that since years. And within the TEL field, we always have these privacy and ethics issue, but we need to move to this to really get comparison results. Otherwise, we only work in our silos, and we are not really sure if one algorithm might be better than another. It's just how smart the people in your organization are. So then the goal of such a study is to find out the best performing algorithm, and we have an own designed algorithm, but we also compare to other algorithms. And then you run that, then we test several recommender systems, we have several similarity measures T-index was the one that was invented by that PhD student, and as reference data sets we used Movie Lens, what is actually not about education at all. It's a movie data set where people rated how good a movie is, what it is about, and so on, and how much they like it. We used the Maze, Open Scout and Travel Well data set and the ODS data set of a specific project, and we used the Mahout framework for this. And it's one objective is also that one of you guys could say, this recommender algorithm is interesting for us. We take this paper, we take the same data sets, we take the source code, and you can replicate what we did, right, with your data, and then we get comparison results. This is why we need, and this is where we need to work to. And at the moment, actually, when you look at TEL papers, most of the papers you just read, and you say, yeah, where's your data set? Where is your algorithm? Which features did you select? And you cannot repeat these kind, and we call it science, but science about having repeatable results, robust results. And in TEL, we don't do that so far. Okay, then you have a training set that's really a training set and a test set, and then you do this testing, and then you get some results. And this, for instance, the results of this recommender study. F1 score is a score that tells you how accurate this algorithm is, and it also tells you the recall value, so how stable, how often they can reproduce these results. And then you have the results of T-index, that was the algorithm from the PhD student, and then Tanimoto similarity and log likelihood similarity, and then we compare that on different things. And that's something where we need to work to within learning analytics to get studies going like this. Yeah? And this is where we need interoperability between data. So that's one of my points. Any questions about that? Any arguments? Any disagreements? Okay. One challenging thing is, for similarity, we have sparsities. A lot of the educational data is very sparse. So there's not a lot of data in, and then the effects are really small, and you actually have to have a rich data set to work with something. Luckily, this does not apply to WOC, because what I learned from Julia, you have rich data sets. But sparsity is an issue, and this is why while we're working, for instance, you have all these European projects, open educational resources for manager, open educational resources for bloody blah, whatever community you want. I think our community had an open educational resource project. All of them had a recommender system within it that just works on this tiny little data set that is within this silo. So what we try to work on, and where interoperability is again important, is to have a standard for social data and also other metadata that is aggregated over APIs or somehow, so that we in fact could have a recommender system or visualization service that takes information from different sources and provide better recommendations to a lifelong learner in Europe or something. Yeah? I mean, that does not fit now to the WOC example, because you want to improve now studying within your organization, so you don't need those actually for your operations. But if you want to have better effects of recommender systems within one project, we should connect those data sets to make better recommendations for a person. Okay, bringing that back, that's a picture of our research program. Yeah, this is macro level mediated learning networks. So those guys focus on learning networks and social interactions and social capital within an organization. Then we have a micro level. I should have introduced, do you know micro, meso, macro means micro is really within a course or face-to-face with a learner. Meso means that it's kind of on a course level. It's the biological course A and biological course B, so it's kind of a layer in between in one domain. And macro really means then, I don't know, the whole organization or something. And that's scalable terms, so you can use them in different ways. So, but these mediated learning networks, people work on a macro level, so they take social networks and then, larger ones. In the micro level, we have new learning experiences where we develop tools like Presentation Trainer that won for the second time at the Actil the Best Demo Award, where you have a Kinect in front of you, and the Kinect gives you feedback how your presentation style is. So how your hands should be, and that you should, I don't know, do the Merkel stuff, that you stand like this, or so it gives you direct feedback. So they really work with this all Arduino toolkits, so really tools, new technology for TEL. And on the meso level, we have seamless learning designs, so different learning designs that affect something. And around all these different research topics, we have the linked open data layer group, what I'm leading. And so what the solution is centralized data storage, or how they call it these days is a learning record store. And the learning record store is really a new kind of technology artifact in the university ecosystem. Because we have this heterogeneous marketing database here, student support there, whatsoever. And this is a system where all this information should come together. Reporting, assessment, so that you have one table, one overview, one view, what's going on with students to do then from here learning analytics. And this is also why we need one language that goes into here. Within the LACE project, colleagues of mine, Tore and Adam Cooper, also when you go to the LACE project website, you can find all these reports for free. They made they looked for aims for data standards. So what are the objectives, why you should do data standards? And they found two of them that's most low-hanging fruits. It should be done now. It's more useful for the analysis through combination of data from different sources, like I explained with the recommender system example. And it's a critical mass of data for learning science research. So that's really something as a community that we need to get a kind of research data set about different, for instance, distance education data set. That is a reference data set where we all can refer to. So where you can do your studies here in WOC, and you also use the distance education data set with that, and then we can always refer to that and develop algorithms, visualizations, and so forth. And we do the same with the Open University data set, and we use that reference data set as well. So we need a kind of authority data set to streamline our research and to develop the whole field as such. And then they identified some others, sufficient scale of data to determine relevance and quality of educational resources. Well, I don't dive into the deep, go to that report, and then it also goes a lot about privacy of different objectives why data standards are needed. And I found this quote of the PAR framework. I will show the PAR framework at the end. Of Ben Best that designed that PAR framework. So without a common diagnosis, it is difficult to agree on treatments for diagnostical problems. Well, think about medicine. If all of the doctors would do like, I learned this from my department, so I think you have this. This cannot be the case. Without agreed upon treatments, it is difficult to measure the efficacy of treatments. Yeah, sure. If we don't agree on things, it's hard. If one cannot measure efficacy, it's impossible to scale. And perhaps the worst of all, we continue to guess about what really works in student success. So that, I think that really packs it in a nice way, why interoperability and communication is needed. And then, well, but interoperability is a field like this. I think we reach not the point that we all talk the same data interoperability standard, but maybe we reach this point that we have a kind of reference where we can refer to. Okay, and then once again, different picture, paper from Marco Kaltz and myself about MOOCs. Can you see that? Oh, you don't see actually the circles. Oh, that's bad. Need to improve that. So that we just submitted that, but the message of this is actually, so here are circles around. So this is micro, meso, macro. And again, if you want to advance the MOOC research as such, you can do that in a micro level by using data, giving feedback, and then you can improve your own MOOC. But if you have a curriculum of MOOCs, then you need a metadata standard, and then you could affect measures of one MOOC domain, like math or something, and see how other students behave on that. And that's also data processing, data sharing, data repository. So also for the MOOCs, it has been specified. The idea comes from Marco, and we have worked together how to advance the MOOC research to really improve that. And it's actually, again, the same idea. We need common language. We need to aggregate things to get better insights. Okay, that have been reasons why data interoperability is needed. If you don't care about learning science as such, then you can leave the room now, because you say, oh, well, I just care about the data and improving work. But if you want to communicate to colleagues, stay here and let's see what kind of data standards are there and how to continue that. So data standards. Just let me make some well, data is data. So what kind of data are we actually talking about? We have content metadata, and then there's IEEE LOM, for instance, is a standard that's there for years. We have personal profile data, IMS ePortfolio, IMS LIB, so there are also different standards already out there. Then we have social metadata. I didn't find a standard for this, too pity, but well, there's ratings, tagging, commenting, and so everything that goes from, that was on the intention of a person to add data to a certain object. That's different to paradata. Paradata is data that's just harvested. So in fact, you harvest paradata about your students without they knowing that you do that, because it's automatically tracked. And then we talk about linked data, what is with Tim Berners-Lee, where he says, well, after World Wide Web, we go now to linking data sets, and that's the new internet thing, where we interlink data sets, and I think we are in the process of doing this with interoperability as well. So now I could continue for ages with talking about metadata standards. I could talk about MOOCDB, what a relational database model is. This is just examples of, there's Activitystream, there's NSDL paradata. There's a lot of, I could continue, I could do the whole talk about this, but that would be pretty boring. So instead I take 4 of them that have been really used. As an example, one is Organic EduNet. That comes from Acronow, what is a company in Greece. We work very frequently, very often together. So they have pushed their standard into all projects they did and harvested it again in one table again. And the Organic EduNet approach is actually pretty simple. It's just you have a description, you have an ID for an object, you have what kind string or whatever, how you save it. You have a minimum value, a maximum value, and a step interval in between. So that's actually the idea about the whole data model, and then they apply it to tagging. So then for tagging you have the rating ID, the user ID, the scheme ID, and how the rating is applied there. And the same metadata schema could be applied to tagging again, element, tagged ID, user ID. So you always get these triples of a user did something. A user tagged something. And then they operationalize that in this way. And this we already did in 2012. Different approach, context attention metadata called CAM. Again applied in different projects, role, Open Scout, Open Discovery Space, just one of the prominent ones. Different research papers about what did they do. Actually, again, the event, the activity between the actor and the object became the central point for following it. And then there's a timestamp, the event type, the idea, and then everything else. Actually, the learner became an entity, like the object. So it's really everything is circled around the event. And that's one of the well, what you see with all these metadata standards, if we would discuss them, it's kind of, it goes about the activity. The activity becomes the central point of what's going on to do the learning analytics stuff. So, and it's actor, verb, object. And now we'll talk about 2 competing standards that are out there and that are the best candidates so far. Don't ask me why CAM didn't become it. Well, there is from the Advanced Defense something, so that's a military invention from the US. You can like it or not, but it's the XAPI standard from the Americans. A lot of inventions come from military, unfortunately. And there's the IMS Global, what released IMS Caliper. So it's XAPI versus Caliper, kind of. The XAPI standard has been released since 2012, and then it has been there, and nobody really did, not too much things happened there. But now we really see a lot of projects and things jumping on that bandwagon of XAPI and apply it. While IMS Caliper has been really within the IMS consortium, there you have to be a member of the consortium, then you could work on a specification, then you applied, this working group applied in the institute, so it's kind of behind the curtains. You did not really, you could not follow openly what's going on there. And they just released in October 2015, I think 1 week ago, they released the first standard. But when you go to the website then, you don't find the verbs and all the definitions like an XAPI. So still the release actually is kind of, hey, we are also there, consider us for learning analytics, and it's very important. So, but this is what we will see at the LAC conference in Edinburgh in April. I think there will be a lot of IMS papers, there will be a lot of XAPI papers, and there might be this kind of fighting formats clash, whatever. I don't care which of them win, I just want to have working solutions. But we applied XAPI in a couple of projects because this have been around and we captured here first experiences with. And this is what I want to tell now. So how does that look like? Activity-driven data model. So you have an actor, a noun, and a verb, and an object. And you have a dictionary of verbs, what can happen, yeah? And that's an example from our own campus implementation. It's like John added is then the verb, a photo to the OpenU, that's our learning management system community environment. Jim commented on John's photo on community environment. John watched how to save energy video on elearn. It's one of our mobile clients. So that's the way how the data goes into our learning record store. So IMS Caliper does that in this way. So they have the learning management system. They have personal learning environments. It's actually the same process. So they have different tools. Those tools have then certain activities. They go to the analytics store, they call it, and then they have different outcomes coming out here. In the new release, they showed this picture. So any systems has a Caliper sensor, yeah, really a software sensor, and that captures an event. And then you again have this actor, action, object thingy. But they are more specified than XAPI. So they directly bound a context to it. They directly bound membership, several things. They have certain tools in place and sensors. So it's more like the IMS Caliper comes with a whole thing you have to apply, while XAPI is just do your own thing, specify it as you want. And both has advantages and disadvantages. Yeah? So this is an example of an XAPI statement within the university. So you have then the actor, so it's nested objects. So you have the actor, an agent, that's me, identified in some way. Then you have a verb. These verbs are specified over a unique identifier. Huh? So the idea, what I'm doing here, I access, indicates learner access the page is even a description, so I use the term access, and that's a unique identifier. Everybody can look up. And then the object that I'm accessing is Psychology Module 1, and the lesson, it's the introduction lesson of that course. This is how the data chunks go to the learning record store. And the important thing is we specified this verb. So everybody can now go and use access, use also this URL for access, and then we talk the same language. Then the WOC students do the same access things like the OU students. And then we can compare our stuff and make synergies or whatever. So within XAPI, they also work on a complete domain model with objects, results, and so on. So things you should consider then when you implement that stuff. And the problem is now still, although there are standards, there are interoperability issues. Why? You can admit, why we still have interoperability problems when we apply a standard? Because you could have things like, Tim Martin launched how to make grilled cheese video. And then it could be launched, but it could also be watched. So the difference is now in the stupid vocabulary they are using. So they apply Catalan and we apply Dutch, and we both use a language. It's basically like this, but that doesn't work. So what is actually needed are kind of recipes how you do it. You need kind of authority how you want to talk, how you want to do it. And XAPI wants to get that bottom up. IMS does that top down. So they define it and you apply it. And XAPI gives you the freedom to do it, but you have to find then a kind of standard and look for this. And the question is how that will end up. So this is why the XAPI people looking for recipes, they call it, so that you then for logged in have a certain recipe. So it's Hendrik logged in to blah, blah, blah with this time. And the recipe goes further, like it also specifies the log out again, so that you have a whole recipe for the interaction of logging in, logging out, and that is specified. So that was a quick dive into metadata standards. Questions on that? Otherwise, I would show now how we applied XAPI for the ECHO project. So ECHO project is a European project again. As I said, we have a lot of them. On massive open online courses, and it's actually a portal. So you go to the ECHO portal, and from there you can see courses of different MOOC providers, and then you can step into these courses and do something there. So the structure is like this. We have a teacher dashboard application, a dashboard that we put to all of these MOOC providers. We have a student dashboard that we put all to the students in different courses. We have the learning record store in between, and we have the different MOOC providers that send us XAPI statements to the record store. And we defined here the language. So we gave them a full, complete list of XAPI statements and how we want to get them, and in which standard, which time format, and so on. So again, you have then the different MOOC providers, edX, OpenMOOC, rlearn, whatever. They send information to the ECHO backend. There's also a profile data layer that identifies the learner, because with all the different providers, we still need to have meta accounts, because you could study here, you could study there, and you have different accounts and URLs. So we need a kind of mega account. Meta account for all that stuff. So, and the learning analytics goes with the learning record store, the XAPI proxy that also validates the statements, and a BigQuery table where we put all the stuff in for the analysis. So again, nobody has seen this picture before. No, that's not true. The people from the project saw it, but we try to publish it now. So we have all these different events. That's actually a picture of our vocabulary, and I think you have that as well. With the different, and then we have the user in the middle. We have then the blog page, and all the different activities that could be there have been specified in XAPI statements. And we say, if you want to do that, please use these terms and send it to us, and then we can provide you with all the analytics and tools we do. That looks in practical like this. We have a list with all, because we have to communicate with all these MOOC providers. So we provide them with a list with all the options that are there. They just can go to learner post a new forum thread. A new forum thread, and they click on it, and they get a complete statement they need to apply and send to us, where they just need to exchange the ID of the learner and some other things, but then it's kind of standardized. That sounds like, okay, everybody should easily work, but for sure it does not. We get then different timestamps and other things, so there's a lot of curation of this data again needed. But this is how we did it. By the way, these Google links are not, I did not put it like this, but you can go there, or whenever you have the slides, and then you find these lists and think about and apply it to WOC or whatever. They go into the article as well, because we want to push that. Now there are not so many examples, and we want to push that out now. Hey, we did it like this way. What do you think about it? Criticize it, apply it, or extend it, and then we can work to a kind of standardized vocabulary. So then finally, that's a bit off topic, but different designs of learning record stores. As I said, within the Netherlands, we have an umbrella organization of all higher education institutes. It's called SURF. It's an amazing thing. So it's a company actually. All higher education institutes pay fees to them, and they organize for the whole higher education level services. So like authentication goes through, you just authenticate over SURF, and you can log in whatever system in the Netherlands where you want to go to. And they also work for sure then on learning analytics and having a vocabulary for the whole Netherlands. what would be awesome to get that. And within that, we have a special interest group on SURF with different partners. And here we exchange also the knowledge like we do now here. So this is how the learning analytics system within the ECHO project looks like. Again, we have the different MOOC providers. They send their statements that we specified, that you just saw on the table, to the XAPI proxy, where they get validated. From there, we store them in a learning record store. But we also store them in a big data table, what uses MapReduce and other things. So actually we keep it doubled. But as we are not totally sure about what learning record store will be the best one for our solution, we want to keep them double. And here we directly do things like MapReduce and predictive analysis and other things with the data. And we push that back to the dashboards in the ECHO portal. So that's our design. Oh no, here are the dashboards. The university, UvA means University of Amsterdam, yeah. They have a different design, what they share with us. So they also have a record store. They have an educational API that's also specified by SURF, what does then query certain points. They also use XAPI like we did it in ECHO, so they adapt to it because they were also short on how does other people do it, so they just adapt what we did here. But they also, and I think that's a very smart thing, and that might be a solution for interoperability, they added an extract, transform, load, an ETL layer, what enables you to extract, so it keeps, it stores the way how you transform data. So if you make from the author-watched video, author-launched video, you put it as a transformation into that layer, and it remembers that. And in that way, they can do their stuff, we do our stuff, but there is a repository of things how to do this transformation and still have a language to communicate with each other. They use Blackboard, the student submission system, and it all goes here too, and then to the learning record store. So lessons learned with XAPI and record stores. So first of all, XAPI has too much freedom actually of choice. Huh? There are so many verbs, and at the beginning we are kind of, what the fuck should we take now? Launched, watched, or what should we do for the videos? Huh? So what is really needed is an authority of XAPI recipes, and maybe we promote ECHO now as a blueprint because we did it, but we are open to, well, to make it something else, but as a first standard to use that verbs. Then XAPI has also language issues because our systems run on Dutch language. This is all English. Huh? So we put in Dutch data into English metadata, but then we need to represent it to a Dutch teacher, and they might want to have it in Dutch and not in English representation, so we have to transfer again to Dutch back. That's kind of silly. So that's something that also has some issues. Then for the learning record store, the ETL layer is a very, I think that's a very smart idea from the University of Amsterdam. And then these meta accounts have been really challenging. In the beginning, we thought we just take the student ID and then we are done. But with increasing data, Twitter, but also, I don't know, think about here these data trackers about walking. There might be effects for learning. So Fitbit might also be a data source we want to have in the future because it shows if the people walk 10 minutes longer, then it has higher outcomes. I don't know, whatever. That is different accounts. And we need these meta accounts to identify a user within in our data at the end. So it's easy if you just talk about the learning management system, but if you apply it like we do in different research projects, in different mobile contexts, and the whole thing gets ubiquitous, you need kind of meta account solution. And then one final thing, are activities all we need? So I mean, XAPI, IMS Caliper, it's all about activities. It's all centered about activities. But what about text-based analytics? What about written text? I mean, especially distance education universities, we run on text. And text is very important for communication and for quality. So we also store the text, but all these approaches that I just showed to you are pretty much just on the activity metadata thing. And I think text is kind of under the table and needs to be get more attention. Oh, that should be animated. So there's, in Amsterdam, we are organizing with Surf Together and the LACE project a code jam, a hackathon kind of thing for XAPI, where we have the example data there, we have an example learning record store there, where you can come and just, it's free of charge. You can just come there, play with the data, talk to other hackathon people, other hackers in that domain to get interoperability going, to test patterns that are working, present your own approaches and so on, bring your own data. So that's a code jam. And then that's 2-day event, 8th, 9th of December, and on the 10th we have an institutional readiness day of the LACE project, where we also want to embed, bring the policymakers, the managers, but also the teachers to see how ready we are with implementing learning analytics. Talk to them learning analytics, tell them about show some best practice examples, show some bad examples, but to get it also from the IT department to the actually teaching to the departments, what's very important for us. Other initiative by JYSK. JYSK is the umbrella organization of universities in the UK. JYSK just started another huge project also for learning record stores and XAPI. So they're also on the bandwagon of XAPI, and they launched before the LAC conference the Connection Forum, where they also want to do actually the same exercise. They want to people come there, show XAPI, compare recipes to get this community-driven standard. Also another opportunity. And then I finally want to show you one slide that might make all these things that I talked to you unneeded. But, well, it's just a claim, so let's see. You know, there was there's the PATH framework. The PATH framework is a system, basically. No, it's an organization, again, in the US, where they need 77 data points. Yeah, going like in register date of the student, language, domain, course, whatever. 77 data points, indicators. They put it into the system. Then you would put the WOC students into that system. They have a consortium of 20 universities, so they have kind of big data of all different universities and have prediction models. And then they would use your data compared with the others and give you then the predictions back to you. So you don't need to do the prediction on your own. They do the prediction and the stuff. They do it in a private. You can send it anonymized, and then you can get certain things. There was just last week a new MIT article released of an automated data feature engine, where you give then the data set, and you don't need a data scientist anymore. So this engine identifies the important things and gives you then the predictions back. So maybe even that's not needed anymore. So there are scary things going on. But so that would all these standard things maybe make unused. You don't need them anymore. I have doubts about that. Because if we would put our Dutch students to the American education system and trained models here, that will not work. We have a different education system. Distance education is different. So you would have an engine that predicts something that is trained by schools for your organization. So how should that work? So, but maybe we could establish a PATH framework for distance education in Europe. And this would be a big debate, but just one idea. That's my talk. Thanks.